Hey guys, what's up? In this video, you are gonna learn about Internet Protocol or IP, and you will also learn what is or about IPv4 address. So let's get started. First off, we will learn what is Internet Protocol. It is a method or a protocol by which the data is sent from one computer to another computer on the internet. Every computer has at least one IP address. There are two versions of IP protocol, that is IPv4 meaning Internet Protocol version 4 and IPv6, that is Internet Protocol version 6. Today we are gonna learn about IPv4. IPv4 it provides about approximately 4.3 billion addresses. It uses 1 byte decimal number separated by dots. Example 192.168.1.1. Now that 192 is 1 byte and those are separated by dots. It is a 32-bit address. Now let us learn the header format of IPv4. Here in the above picture you are seeing the IPv4 header. Header is a format or a part of data packet that carries the metadata or other information that is necessary to transfer the main data. In the figure is the IPv4 header format. Now let us take a look of all the parts one by one. First off, there is a version section. Here you can see that is of 4 bits. It indicates the version of the IP address, that is it IPv4 or IPv6. Moving on to the header length. It contains the length of the IP address. It specifies how much length or how much size is this IP header. Moving on to the type of service, it is used for the quality of service, meaning how the packet should move. Either it is TCP or UDP protocol. Identification, here you can see it is of 16 bits. The header is divided into two parts, that is of one of 16 bits and other of 16 bits. You will learn about it just a second. Now we were talking about identification, that was of 16 bits. It is used for the identification of the fragments which was fragmented in the data link layer to reassemble in the same way we use in the identification. I have already taught you about frame and fragmentation in the last video. Now as the data packets are fragmented, we need to identify which fragment is belongs to which fragment. So for the identification, all the fragments are assigned with their identification code so that it can identify it a bit easily. Moving on to the DF bit. Here you can see the DF bit. Now it informs whether the datagram or the data packets can be further fragmented or not. When DF bit is set to 0, it grants the permission to the intermediate device, you can say that router, to fragment the datagram or the data packet. When DF bit is set to 1, it indicates that the intermediate device is not allowed to fragment anymore. DF bit usually specifies whether the intermediate device can fragment the data packets further or not. Moving on to the MF bit. The MF bit, it informs whether there are more fragments of the data packet or it is the end or it is the starting. It specifies whether the packet it has received is either the starting or ending, or it will also specifies either the fragments of that packet is about to come. When MF bit is set to 0, it indicates that the current datagram is either the last fragment or the only fragment. When MF bit is set to 1, it indicates the current datagram is a fragment of a larger datagram. Okay, if MF bit is set to 1, it indicates that more of the datagram or the data packets are about to come with that same packet. Moving on to the fragment offset. The fragment offset is used to identify the sequence of the frames, whether it is a first frame or intermediate frame or the last frame. It is somewhat similar to identification, but here it is used to identify whether that frame is a first frame, intermediate frame or the last frame. Moving on to the TTL. TTL meaning time to live. It indicates the lifespan of a data or a frame. If the value of TTL is 0 before reaching the destination, then that frame or the data packet is discarded by the intermediate device. At the destination, the TTL can be greater than or equal to 0. If there is no TTL, then there will be a congestion in the network media and there might be a possibility that all the network devices might hang up. Moving on to protocol. It informs the network layer at the destination host to which the protocol, the IP datagram belongs to. It specifies the protocol which the header format is or the IP packet is using. Moving on to what is header checksum, or it is also known as error checking. It is used to check any error in the data. Moving on to source IP address, it contains the logical address or the IP address of the sender. Destination IP address meaning it contains the logical address or the IP address of the receiver. Options, here you can see options. It is of it can contain about 0 to 40 bytes. It is optional. This field is used to record root, source routing and padding. Now let us learn what is record route, source routing and padding. Record route meaning it records the IP address of the routers through which the datagram has passed on its way. Source routing meaning it is firstly decided that from which direction the datagram must be traveling to reach the destination. Padding meaning it is the additional data that is added which is of no use so that it can accommodate the unused space. Fields that can be modified is TTL meaning time to live, options, datagram length, header length and fragment offsets. These are all the fields which can be modified further. That's it for this video guys. In the next video we will look on of IPv6. Until then, stay tuned.